that. So we know that this is just going to make a stack of boxes. And we know if we run it, we're going to have all kinds of issues down here, which I would do in my class and spend time explaining why those are issues and what happened because we changed that declaration and that's no longer available. But we don't need to do that since we all follow that concept. So we know we're just going to vary this X, and I'm going to use the same formula we did before. I'm just going to take the I, so it lets me reiterate that the index is nothing more than an integer. And then I'm going to multiply that by however big the rectangle is and plus whatever little buffer I want between. I don't know about y'all, but my students consistently struggle with that for loop. They think that I is just magically some shape or something. They just really struggle with the fact that it's not anything other than an integer. So that's going to make it. Now we need to go and start moving it. So this is a great place for an enhanced for loop. Again, depending on when you taught for loops, some of my students still resist the enhanced for loop. I don't see that as much with my Python students as I do with my Java students, but they just resist it for some reason. I guess it just depends on what you learn first. And then for now, I'm just going to take the bouncing out just to prove that this guy works. Sweet. Okay. Kathy, I'm seeing that a lot more now too. I see a lot of mine that now do not want to use a traditional for loop. They'll use an enhanced for loop and add their own little variables to it. It's funny, but then I have some that just fight me on that. All right, so now let's fix the bouncing part. So we know when we're looking at that group of objects bouncing left and right that we're really talking about the guy on the front end and the guy on the back end. So what I encourage them to do is use temporary variables. It's not necessarily the most elegant, but I think it helps them in preparation for the AP exam. So I'll initialize this first one as boxes 0 and rectangle right. Dang. Will be, bless me, boxes dot length -1. Now, some of you are already cringing because we know we're going to have a problem with that as we start removing boxes. But I try not to tell my students anything that they can discover on their own. It makes class sometimes long, but I think they do better if they've made that mistake. Okay, still working good, still bouncing. All right, I would be remiss if I didn't clarify something here. So let's talk a minute about line 29. Some of you, and I'm one of these people, so some of you that have been teaching many years cringe at this write.x. We want that to be a getx. So then this is where Noah, the student that wrote this, and we argued about this for 2 days. And I won the argument, but I think he finally won the war because I had him write a whole new different Java draw library just for AP teachers. Now, I'm not using it because I've come to determine that he was right. But there is a version, if you just do javadraw.ap.star, that all these accessors and mutators are getters and setters with the words get and set. I wanted get and set in there because they see that on the AP exam. I understood his argument that the more modern languages are getting away from that. And the more I was using it, the more I found myself getting frustrated by having to write the word get and set and remember which is which. But if you want that, if you want to strictly enforce that accessors need getters and setters need the word set, just do javadraw.ap.star and all those shorter accessors and mutators are gone for you. But I'll never tell him he was right. All right, so that gets that guy moving back and forth. There is an auto formatter. I can't remember the keystrokes. Joe, maybe? Can you remember? I can't remember what the auto formatting is. There's a keystroke for that, but I just don't remember it. All right, so now that we've got our boxes bouncing, we need to also have them move down. And yes, you're right, they are sloppy. I say, Joe says, highlight everything, do command palette. Oh, okay.
And then format, look for type in format document. You can start to type it in. I don't know why it didn't show up for you. Oh, maybe because you only highlight a certain section of text.
Oh, maybe so.
F1 is always the command palette too. Format.
Okay.
FORM. Or.
Huh. Okay, we'll pretend that.
Yeah, mine has format document. Shift Alt F. Oh, I'm on a JavaScript. I happen to do it, so maybe Java doesn't have it. Sasha's saying.
Oh, okay.
I know I do that in Python.
All right, so we've got our we've moved our boxes, and now we've bounced our boxes, and we need to move our boxes down. So right inside, we would have a discussion about where that should happen, and hopefully they'll determine that once those guys bounce off of one side or the other, that's the time to move them down. And I know that we're going to have an issue coming up later with using enhanced for loops. So I'm always asking them, even though it's pretty clear, I'll say, what's the most appropriate here? Do we want to use a for loop and indexes or enhanced for loops and just let it do it for us by reference? And they'll say enhanced. So we're like, okay. And we'll figure out later on if that's going to be a problem for us. Man, if my students saw me typing today. Again, we'll test it. All right, all that's working. Okay, we're going to do a little more setting up and then getting to our problems. So now we need our little launcher. Now I'm going to do this one a little different than we did in Python. This is not going to be that pipe shaped one. This is going to be more that traditional one that we're used to from the old days, just like a paddle on the bottom, just moves right and left with us. So just be aware that's what we're going to do. All right, so I'm going to go up top. I'm going to make me another rectangle. It's going to be called launcher. And yes, I should be putting private in front of all of those. I just didn't, just don't tell me. And I'm going to go inside my start and go ahead and make my launcher here. It's going to be a new rectangle. And just like always, we tell it where to be, which is on the screen. And I'm going to do screen.width divided by 2 because I want it in the middle. And then screen.height. I'm going to make it probably 50 wide and 60 tall or so. It's going to be sticking off the bottom of the screen, so I got to do some sliding up in just a minute anyway. In this case, I would not run it. I would talk to my students and say, okay, where is this going to be? They're going to say it's going to be in the middle of the screen, which is not technically true because it's going to be slightly off. Objects are anchored to the upper left-hand corner, and it's going to be at the bottom, so we're not actually going to see it. So they've got to move it up. So we got to do launcher.move. I'm going to just leave it right there for now, and then just move it up a little bit so we can see it. And there's our guy down at the bottom. And now we want him to move when I move the mouse. So I'm going to go down here to my mouse move method. And since the mouse movement is not dependent and does not accept anything to do with buttons, that's why there's no other parameter for there except the location. And all we're going to do is just tell the launcher to do this. We can deal with the X and Y if we want to, but when Noah wrote these and he made these objects, he gave us an attribute for every object in JavaDraw. Whether it's a custom polygon, you can tell it you just want 8 vertices and give it the size and it'll make it fit. Whatever you can do, you can just give it a collection of vertices and it'll connect them all, but it'll always calculate a center. So everything has a center. So we can just say, hey, launcher, I want your center to be at the location X. The location happens to be the mouse location. And I want you down at the bottom of the screen. Remember, that's the center of it, so half below and half above. And let's run that. It should be following. And then there it is. Okay, now we just need a projectile. So to save a little bit of time, we're going to be creating a projectile every time we click. So in class, we would have done 1, then 2, then 3, and they'd realize this is too many to keep track of, and you don't know how fast people are clicking. So hopefully they come to the conclusion that this should be an array list and not an array, since we're going to be adding to it and taking away from it. So we'll go up and declare one of those real quick. So I'm going to do a list. In this case, the base shape is going to be oval. And I'm picky about accurate names. So I want it called projectiles, not P or anything like that. And it's going to be a new array list. And I'm picky about them putting the data type here. And that also means we need to import our utility. Some of you are already seeing, again, that advantage of coding rooms, because I'm saying things that we all know, but we don't always remember the syntax. And so if you weren't in coding rooms and you couldn't actually watch me this closely and copy and paste back and forth, you'd already be behind, and your students are the same way. So this lets me actually go a little bit faster, because I will stop like I'm doing now, talk a minute or so to kind of let some of the slower ones catch up, and have an advanced talk with some of the other students. All right, so I've got my array list. And what I'm going to do is every time I click the mouse, I want to create a new oval. So that brings us to another mouse method. And we would guess this, or we would look at the documentation and find it, but typically they'll figure it out. It should be public void. And in this case, it's mouse down. There's also a mouse up. Mouse down takes 2 parameters. It's an integer that will tell you which button is actually pressed, and then the location. And then what I'm going to do every time I press the mouse, I'm going to create an oval. And it's going to be down there on top of the launcher, down at the bottom. So in this case, I would have the students work that on their own, or they can just follow me if they need to. That's why I told them what I was going to do, and now I'm going to do it. They can do it on their own or do it with me. So I'm going to make an oval called a projectile. It's going to be a new oval. As always, it's screen. And then where I want it, in this case, I want my oval to be in the center of my launcher. Specifically the X value of that center. See how we can talk about chaining and concepts like that in AP just by using these. And then I just want just the Y value of the launcher, just up at the top is fine. Now I'll go ahead and make it 2020 and just make it some color like green. Wow. Whoa. Once I create it, we're going to go ahead and add it to our collection. And now we got to go up and move these projectiles. I'm going to run it. Again, that allows, the reason I'm doing it, number one, is I really want to make sure it's working. You can see it stacking up down at the bottom. But again, it lets that slower student catch up without having to raise their hand, because I'm taking a second to test it and look at things, and it's letting them look at my code and see what's going on with their stuff. All right, so now those projectiles have to move. So we know that goes back to the cycle. You can't see me, but I'm rolling my hands. That's just my signal they see for 4 years for some type of loop. We're inside that loop, and we've bounced our boxes. We've checked to make sure that we bounced our boxes. We've moved our boxes down. We've actually moved the boxes. Now I need to move the projectiles. And again, we got to ask, is this appropriate enhanced for loop or traditional for loop? And I can tell you they're going to say enhanced for loop. And we're going to say, okay. And then I'm going to tell my projectile to dot move 0, -10. Now, I told you earlier that JavaDraw and PyDraw are parallel graphics libraries. So these objects also have forward and stuff like that, just like the graphics did in Python. I just don't use it in AP because they don't really see it that way. And I know in the future what I'm going to do is we're going to make some advanced classes that they're going to override all these methods. And I don't want to give them 50 methods to override. I just want to do some basic moves and move to. So I kind of just stay away from some of the fancier stuff it'll do, but it will do. You could literally copy the code from Python and make a few changes to it and it would work. All right, this guy's going to be moving up, and hopefully we are on the right track. And there they go. And we're good to go. All right. Now we're going to have them hit the boxes. And this is also a good point to tell you one thing that shocked me. And Sasha, honestly, it did shock me the first time I did this exercise with my class, because normally I do this on my Mac, and I would just click away, click away. And some of you already know that because it's an array list, yeah, it's constantly growing. All those projectiles are still there. They're still moving, and I could quickly start slowing it down. It takes me a lot of clicks to slow down coding rooms. I mean, I'm still clicking. And you think about all those objects that are being independently animated going up, that array list is doubling in size every time it gets exponential growth, and it's still just chugging right along. So it didn't let me prove my point because it ran too well. But this is normally where I would have that discussion, is we're being very wasteful because there's so many projectiles out there now that we're not even using, but we're having to deal with the overhead of cycle back through there and tell them they're moving and eventually see, are you hitting these boxes? And it's eventually going to cause us a synchronization issue, a discussion that we avoided in Python because Python was just introductory. We were just having fun and it didn't matter. But here they need to really analyze, start thinking about what are you doing? So I had to find another way to show that with them. And that's what we're going to do next, is show them what's really happening. All right. So, and I know I'm going fast. Sorry, I talk fast. So now let's start removing some boxes. We need to see if these guys hit. So while those projectiles are moving, I want to check and go through each of the boxes and see if they hit. So notice I said I want to go through each. That's my hint to them to use a for each loop. I'll go through each of those boxes. So for each rectangle box in boxes, I want to see, just like in PyDraw, JavaDraw has a method for us to see if two shapes overlap instead of us having to do the math. I would still have them do the math originally and then go back and use this method, but we're going to save time and just say if the projectile overlaps the box. We're going to do something. So we'll do something like box.color. I'll just make a new color, 155, 155, 155. All right. Now, we know in this game, when we run this, we hit that box, it's going to change colors. But what we really want the box to do is to go away. We're just using the color change to prove something. So a couple of ways we can do that. Number one, we can just take the box from the canvas. I'm going to say box.remove, and it removes it from the screen. So the color change isn't necessary, but it's there. And these students will think, wow, I did something. And they'll think, okay, I'm done. The game's almost won. You and I kind of know, in fact, you just saw it, that just because they're removed from the screen doesn't mean they're not interacting. So watch, he's going to bounce because those other guys are still there. They're just not visible. So this is the other way I was showing them that we've got a responsibility as programmers to deal with that. That's overhead we don't need. Plus it's making the game not behave correctly. So what I'm going to do now is ask them to keep track of it. So we do this sometimes. It's called, I call it inside out programming. But right here, I'm going to write what I want to happen and then back up and add the stuff around it. So what I want to know is every time I hit something. So I want some hit counter to go up. I want the hit counter to be displayed on the screen. So I need a text object right here. So I'm going to make a text object called status. I'm going to assume it's already made. I'm just going to update its text to say my hit count is this. So that's what I want to happen. Now I've got to kind of back up inside out programming to put in everything I need wherever I need it to make that happen. So I got to go all the way up. Define me a text object up at the top. Down here, I'm going to create my status. As always, it's on the screen, what you want it to say. And where I want it, I'm just going to put it 1010, it's fine. And I'm going to make it just some random color just to show that that happens. I'm also going to set its size to 35. Now we're moving fast on this one. And this is where I would tell my students, if you don't get this exact, just hang on, you'll have this code available. You can go ahead and fill in the details later, but hang with me because I want you to see what we're doing. All right, so I've got me a hit counter at 0. It displays on the screen. Size is 35. I'm going down here into my while loop. And every time I hit one of those boxes, that counter is going to go up. Now I can prove to them that those imaginary guys are not there. Oh, did I not declare? Oh, God, did not declare. Look at that. Did not declare my hit count. Okay, and now they can actually already see it happening. Some of your kids are going to be saying, wait, it didn't hit it. How did it hit it 8 times and 2 of them are gone? So now they're beginning to understand that just because I removed it from the screen doesn't mean that they're actually gone, and they can actually see me start hitting things that don't exist. So now we have that discussion. How do we fix that? And if we were using array lists and arrays, now I got to deal with whether something is visible or not, and how do I get things out of an array list? So now I was able to use this to hook them and let them understand, holy mackerel. I was just going through writing code and it looked like it worked, but in theory it did, but there's a lot of problems. And my problems are right in here. Something else has got to happen with those guys. I can't just remove them from the screen. Maybe I should just remove the projectile. And we know that if I remove a projectile using an enhanced for loop, it's going to give me a concurrent modification issue. In fact, I'll just do it just to prove it happens. not going to hit them. And so now it lets us now have a whole day's discussion about what can and can't be done. Why, in this case, maybe the enhanced for loop wasn't the appropriate thing for us. Maybe now we should have done a normal for loop, and maybe we should traverse it backwards so we could remove elements from it. Maybe we need to think about some whole other concepts available to it. So to me, when I saw this type of discussion, that, and I've taught something like this for years, but it never happened better than it did last year with coding rooms. Now, I'm not saying it's magic and it just, you know, all that happened, but the connection it gave me to the students was far better than ever. And I just always assumed I was always in touch with the students because I was walking around hovering over their shoulders like the rest of us. But there's just so much power in this, and they are so tied directly to what you're doing and doing it instantly. And me being able to pop over and look at their workspaces and see exactly where they are and where they're stuck. It just couldn't happen before I started using coding rooms, and it just allowed us to do so many more advanced programs. And I'm sorry, this is just ended up me just rambling for a while, but I wanted you to see how I use the same assignment that we did in Python for first year students and was able to scaffold it up to now second or third year students, depending on whether they take AP Computer Science A. And this thing can get very, very extensive quickly. And because of the use of Java Draw, the graphics are not a problem. There's no headache of all that stuff that's necessary with some of the other graphical and some of the game environments. These things are just kind of easy to work with. But anyway, we're running out of time, so I want to see if you have any questions. I'm going to look and see if I've missed anything. Overlap and move, they live, the base object for all of our objects are called renderables. And so the definition of a renderable has that in it. Now, I will be honest, say the documentation on Java Draw is not nearly as extensive as it is for PyDraw, because you did PyDraw first. But if you go into the documentation, there's a section over here called renderable. And this is everything a renderable item can do and how to do it. And there's your overlaps and your move and move tos. And this is also the power of, it really helped my student Noah, and he tested with my other classes, but it really lets you spend time and teach students how to dig in for these answers like this. That's what they're going to need to do anyway. But how about other questions I might can answer? Let's see, so as long as Java Draw is imported, this can be done. Absolutely. Kathy, that's, I was so appreciative of coding rooms being able to work with that and pre-installing that for us. So my first year students that I've never seen before, we're going to be in coding rooms day one doing a graphic assignment. Now it's going to be something very simple like the old touchy window or something like that. But they will have something that works that they can go home and show mom and dad, either on their Chromebook or their phone or their iPad. It's the exact same, only thing you add is a .ap. So it's javadraw.ap.star. Again, they work exactly the same. The only difference is the accessors begin with gets and the mutators begin with sets, but everything else is identical. And we've debated, I'm trying to encourage him just to put them together. He does not like the idea of two methods doing the exact same thing with two different names in the same library. So right now he's winning that argument. Sometimes you just have to let a high schooler win. All right, anything else? I know I've left you off with not a perfectly working program, but there's one at least you can play around with if you'd like. This is both. His question, if y'all didn't see it, is, was this an assignment or was it lecture notes? It was an assignment that we do together. And what I would have done is done a little bit each day, or maybe the first part of class, then left them with work time, and then say, hey, for those of you that might be struggling with the bouncing part, I'm going to go over that in a few minutes. And if they don't need me, they don't have to tune in, but they always know it's there in coding rooms if they need to glance over. But so it is an assignment they would turn in. I would not have done it all with them. I would just give them clues and then just kind of leave them with a working shell, but with problems they still need to solve on their own. Students cannot see my assignments. They can only see live classrooms or any workspaces that are specifically shared with them. So I will also use a workspace and just demo it, but for them to have this interactivity, it had to be a live classroom.
I apologize for asking the question out loud. Can you hear me?
No problem.
So I guess I'm confused. So is it just workspace items that the students can see, or you could be just, hey, you open up an assignment and you start there and everybody can see that and copy the code and basically do everything that you could do with the workspace. I'm confused with this workspace and assignment difference. Basically, I want to be able to demo both pieces, an assignment and workspace.
Sure, absolutely. And I appreciate that question because it took me a little bit of time to understand the need for both and that they don't necessarily live together. So one of the ways it kind of helped me understand is a private workspace that they create. It's kind of like a notebook they have in their book bag. They can do whatever they want to. It's theirs. I'm not going through their book bag looking at it. Now, if I give them an assignment, then that assignment is its own piece of paper and they work on that. Or if we're doing a live classroom, they have a live copy of whatever we're working on. So those are, to me, the kind of three different areas. There's a live classroom that we're all working together simultaneously on. There is an assignment like a test or an old-fashioned worksheet I would give them where they do stuff and turn it back in. But then they can also make their own workspaces, which are just stuff that they have in a notebook, programs that they're working on. But I don't ever see those other workspaces unless they choose to share them with me or ask for them.
So sorry, follow-up question. Okay, so that live workspace can show, you can demo an assignment or your workspace in live classroom.
Live classroom, yes, ma'am. That's what you're seeing now is you're seeing my presentation, which happens to be a workspace for me, alongside with you having a temporary workspace inside of this classroom.
But you could have just easily opened up an assignment and made that in live classroom.
I could have opened up an assignment, but we could not have done this interactivity.
Okay, okay, there you go. Okay, thank you.
Absolutely, I appreciate the question. And yes, it is for students to get exposed to the style. And I like the fact that we can, when something really gets tough, instead of all those students working by themselves, sometimes we just need to big brain it together. And the differences in the Java draw.jar and Java draw.ap. They're all, it's just that .ap. They're two separate files if you choose to use them for now. I'm hoping to win that argument and they all go to the same one.
I got a question, Barry. On APCS A, I'm looking at the typical syllabus that I have, and it seems like, but I need to check with you, that I could start with basic identifiers, how to initialize them, like say for boxes, and then I can graduate onto loops. Maybe I have a loop and maybe a scanner input where you say, how many boxes do you want to put on the screen? And then they type it and then it just pops out. It's a lot simpler than what you have. What you have here is more like way towards the end of the school year where they're doing arrays and all that. But I like to start them generally with simple concepts. So I say, okay, so I'm basically asking, can this be done? Or are you already doing this now? Where you say, okay, class, today we're going to do while loop. So in the while loop, you're going to start by asking how many boxes do you want, or what size do you want them, and they type that through the console, and then and then it doesn't animate, it just draws them, say, in random locations. Okay, so I figured this is a way of teaching them input output using scanner. Also a loop that automatically places them in certain spots on the screen. Is this kind of the way you have your class organized? Because I'm looking for a graphical motivator to like a stage to put the standard APCS A material, which has no graphics in the actual exam. But if you have graphics here, learning these concepts could be a great motivator for my students.
Absolutely. And you said that perfectly. And I really appreciate that. And yes, sir, I do that depending on the class. I'll hold their hands a little bit more, and we will start out with some very simple things. Like you said, maybe just a rectangle. Then we'll learn about colors and maybe clicking and making another rectangle. Might be a good idea to talk about random numbers and do some math with the different sizes of the rectangles. Then maybe later on, we'll do a quick little while loop. Maybe not even explain how it's working, just use it like a little timer or something. And then as we need, just keep adding more and more stuff to it. And then there's some days when we just do just straight old fashioned book work. You know, we just, this is not a graphical day. This is just something we got to do some math and hand sorting of items and stuff like that. And Kathy, you had asked a similar question about when I start this. I really do like to do something day one, because you know how mom and dads, when you get home, they'll say, what'd you do today? So I like them to have something that worked. And also if I can do that first day, if they can't do it, you know, if it really is over their head, we have such a small window for them to drop the class. It gives them time to go ahead and understand, wow, they're going to move fast. And if I couldn't do the first day's assignment, I need to move on. And then also, I think, forget Rich, I think, had asked how you could access this stuff. The other advantage of this is my unit, and I would never end this live classroom. So students can go back into this live classroom at home and get back into their workspace and back into mine, and they can still work on it. And so I leave it as kind of a live notebook. In fact, I would stay in the same live classroom for the whole unit is what I tend to do, and just add more files to it. So that live classroom becomes a unit. It has several little things in it over here on the side.
Yeah, I was thinking also of like having them draw the Olympic rings, those 5 rings.
Oh, yes, sir.
Something also that's perfectly great here. And I can grade them on like, well, these rings are not the right size, guys, or they're not placed overlapping correctly, teaching them to not hard code magic numbers to each location, but maybe set some numbers in the beginning that will tell them how big are these rings going to be and where they start.
Absolutely, I like that a lot. And they'll come up with their own ideas. I mentioned this in the Python class. When you start doing a few simple things, and in fact, this is how I started years ago when I do an object draw. We'd put a few things on the screen, and somebody would say, that kind of looks like such and such, or can we make it do this? And so we start out with putting a few things on the screen. Then we do what's called 3-button roll. There's 3 things, and they just randomly choose a color. Then they start adding them up. They do 9-button roll. All of a sudden, they realize they can do tic-tac-toe. And then they can do tic-tac-toe. They want an animation, then they can flip something. And then we moved into a Christmas project or a holiday, a celebration of winter solstice project, whatever you want to call it, which got us into further animation and got us into classes and collections. And then we started putting things on the tree and sorting ornaments by size or average red number or stuff like that. So it all just kind of built itself. But I let the students kind of direct it. But they're definitely more hooked if you can get the graphics on there, and it's simple graphics that won't confuse them. And there's resources for your advanced students to come back and show you that over the weekend they made Tetris with it. And you'll be like, oh my gosh. Because they'll do it if you can just give them the resources and show them how to use it. But anyway, I did not mean to run over time. I'm sorry, I got to talking, and that extra cup of coffee fired me up. But I really I appreciate what Coding Rooms has done for my classroom and our content. And it's just always glad to share.
Everyone, you'll notice that Sasha put the exit poll in for this session, so please give that a click. and do that. Barry, it was no problem at all for you to go over, because as you know, I love this topic also. Barry and I have had many conversations. We both have similar philosophy with putting these graphics in as early as possible into courses and getting them to play around and have visuals throughout the experience. So
Yes,
awesome.
Joe was very instrumental in getting me with coding rooms. He's the first one to mention it to me. So I appreciate that too. It's made a world of difference.
And we just love how all the graphics runs on coding rooms. As we saw in this demo today, you couldn't even slow it down.
Nope, couldn't do it.